All right, we have reached one of our final calculus lessons. There's only going to be two more after this, and this may be the last time you ever take a derivative. What? No way. The next topic is called optimization. What the hell is that supposed to mean? Well, that's what it's supposed to mean. So look, companies do this all the time. The process of optimization is maximizing or minimizing. If you're a company and you build something, you want to minimize the amount of your product that you make and maximize your profit. If you make too much of the thing and it doesn't sell, then you wasted your money. Companies do this all the time. So, max, min. Max, min. Those sound really familiar to me. I could swear I've seen them somewhere before. I wonder. So, look, the reason you do the graphing lesson before this lesson is because you learned how to find the max and min during the graphing lesson. So you already know that you find the high point and the low point by taking the derivative and set it equal to 0. And you get those critical number thingies. And those critical number thingies are always your max or your min. So here's a quick question. I want to find two numbers whose sum is 500 and the product of those numbers is a maximum. Now, you could have, say, 1 and 499. You could have 5 and 495. You would write the two numbers down. I mean, look, you're not going to do this. I'm just showing you. Just making up. You know, you might have 100 and 400. There's a lot of numbers. And again, assume they're going to be whole numbers. There's a lot of numbers whose sum is 500. And then what you would do is you'd multiply them and figure out when I get the largest product possible. Now, this is completely impractical garbage, and I'm not going to do that. I'm going to try to make an equation. So here's my equation that I just created. The sum of two numbers, one number, two number, is 500. I want to take a derivative to get the maximum. The problem is I have two letters here. And it is a problem. I can't take the derivative of this. I mean, this is just an equation. The sum of two numbers is 500. What I am trying to maximize is my product. I need another equation. I'm going to take the two numbers whose sum is 500 and I'm going to multiply them together. I want that product to be as large as possible. So I'm going to write a big-ass M for maximum. Could be minimum, too. The problems are always designed to work out that way, so don't freak out. It's like, how do I know if the number I get is a max or min? If the problem asks you for a max, the answer you get will be a max. If the problem asks you for a minimum, the answer you get will be a minimum. I guarantee you they're just rigged that way. So don't worry about having to determine whether they are or not. You just get the answer and you'll see that it's done. So I need two equations. Now the question is why? Well, this is the equation I'm trying to optimize. I want the maximum product. So I'm looking for an x and a y that will give me the maximum product. So this is the bad boy that I want to take the derivative of. But I can't take the derivative of it with two different letters, unless you want to sit there and try to use the product rule. It's not going to work. So I'm going to solve the top one. So we're used to using x. I'm going to solve the top one for y, and I'm going to plug it into the bottom one. So I hope that I don't have to explain to you the third grade math that you just subtract x to this side and get here. I'm also hoping that I don't have to explain that I'm going to take the letter y and replace it what it is equal to with x. So this is called your max equation or optimization equation. I mean, it could be min equation too. That's why I'm using m, because m works for max and it works for min. Yay! One letter for both things. Laziness. So you distribute this out, right? Now, back when you did the graphing, how did you figure out where the graph was increasing and decreasing? You took the first derivative, you set it equal to 0, and you solved for x. You put those numbers on a number line, blah, 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 blah. You don't have to do that as much here. You do have to take the first derivative. You do have to set it equal to 0. Here I'm only going to get one number, and that's going to be the value of my x. So I'm going to do it. So So poof, I just moved the m over to here, it's easier. I took the derivative of this equation. This is my max equation. Take the derivative, you get m prime, right? Derivative of 500x is 500. Derivative of x squared is 2x. Now, I know that I need a critical number, so I'm going to set it equal to 0, and then I'm going to solve for x. I hope you can tell in your mind what the answer is already. All right, so I solved the incredibly complex equation over here, like you're in the 3rd grade. Add 2x, divide by 2, pow, x is 250. So I wrote it all out in a moronic way. Not that you're all morons, because you're not. Now, if x were 250, I hope you can tell what y has to be. Okay? Just subtract 250 over, so then y has to be 250 as well. So it turns out, right down the middle. I'm looking for two numbers whose sum is 500, 250 and 250, whose product is a maximum. If you list any other pair of numbers that add up to 500 and multiply them together, it will be less than this product, okay? You do 250 times 250, that's the biggest that you get, okay? So this is the concept. You're always going to have one or two equations. Usually there'll be two. You have to do a substitution if there's two. If there's only one, easy, just take the derivative of it. But if there's two, you're going to solve one for one letter, plug it into the other one, take the derivative. But the overall point of this is you take the derivative, you set it equal to 0, you solve, and that's your answer. Okay, so I'm going to write steps. I'll do one more, maybe two more. And then you'll be good to go. All right, I've tried to write you a little guideline. I mean, most of these problems follow a similar pattern. It's not that hard. Sometimes, believe it or not, it's helpful to actually draw a picture. Now, in the first example, it was the sum of two numbers is 500, so what the hell kind of picture are you going to draw? There isn't one, so you don't draw a picture there. The next one I do, you'll see that it'll be helpful that I draw a picture. So draw a picture if you need it. Now, you want to write one or two equations. The first example that I worked for you, I had two equations. So if you do have two equations, well, first, if you only have one equation, that means you only have one letter. So you're good to go. Take the derivative, set it equal to 0, and go from there. If you have one equation, this is a significantly easier problem. If you have two equations, and most of the time you will, you'll have to figure out which of the two is the max equation, but it's easy to do if you just read the question. It says find the maximum product. So in the example I did, I knew that x times y equals m was my max equation. Now again, this could be min. I'm just calling it max for convenience, all right? So it's max or min equation. When you have two, though, since your goal is to take a derivative, you have to make sure that you use the first equation, solve for one of the letters, and substitute it into the second one, like I did in the example I already worked for you. I solved for y. I plugged it in so that my max equation had only one letter, x. Then I was able to take the derivative of the max equation, set it equal to 0, and solve. I got my number. Once I knew what x was, I was able to go back to the original problem, plug in what x was 250, and then I figured out that y was 250. So this is always the general idea of what you're going to do. Write your one or two equations. If there's two, make sure that the max one has the same letter. Take the derivative, set equal to 0, get your critical number, which is the answer in this case. And then if you need a second letter, you go back and you plug it in. This step is not necessary if you only had one equation. That would have been your max equation, and you just take the derivative of it, okay? I think I'm going to work two more. I'm going to work one that's a little harder than the first one, and then one that's significantly harder. Okay, the example. Cletus the farmer. Cletus wants to fence in a rectangular pasture, which is next to a river. He is not going to fence by the river. He doesn't need it. He trusts his animals not to go jump in there and drown, and they're going to go drink in the river anyway. He has 2,400 feet of fencing altogether. I want to find the maximum amount of area that he can fence in. So here's Cletus. Here's his little rectangular area. Here's his river. Appreciate my artistic integrity. Now, length, width. So look, sometimes it's helpful to draw a picture. So there's Cletus. He's going to fence in next to the pasture. So he has animals that he wants to keep. He wants them to be able to get to the river. Now, area is the space inside, right? So what Cletus is looking to do is figure out what dimensions he wants. You know, am I going to do 1,000, 1,000, 400, 800, 800, 800? I mean, he wants to get the most space that he can. And it matters. The amount of the length of the sides that he chooses determines how much area his animals are going to have to go all over the place and go crazy. So, I mean, it is what it is. You got to start making equations. So I want to talk this through rather than just have it magically appear, though part of it magically appeared. Look, I'm making a rectangle, okay? I'm not fencing along the river, so I'm missing the width. You want to do WW, but that's not how you make a rectangle, right? I mean, you do length, width. So I have 2 lengths and a width. This is the amount of fencing that I have, right? So he has 2,400 feet of fencing to use. So this is my equation. Whatever I decide L and W are going to be to maximize the space inside, it has to add up to 2,400. I mean, I can't use 3,000 feet of fencing. There would be a bigger area. All right? It doesn't work. He only has 2,400 to work with. So I'm looking to figure out what L and W are. So what I want to do is I want to maximize the area. Now, you know the area of a rectangle. It's length times width. Now you're saying, but wait a minute, you didn't fence along the side. That doesn't affect the amount of space inside this rectangle, right? Whether this side is here or not. I mean, we're not talking about perimeter. We're talking about area. Area is the space inside, so you don't give a damn if the side is not there, okay? So I'm trying to maximize. Again, I'm going to use big-ass M. You could put A for area. I don't care. And then you'd have A prime, whatever. I'm just using M for maximum, all right? So now I have a very similar situation to what I did in that first example with the 2 numbers adding up to 500. I have 2 equations and 2 letters. I need to take the derivative of this, so I have to get rid of one of them. If you subtract W, I'd have to divide by 2. I'm going to be smart and lazy at the same time. I don't want to solve for L, okay? Because then I have to subtract W and then divide by 2. That's more complex. I'd rather just solve for W, because then all I'll have to do is subtract 2L. So this time, I'm going to solve for W. It's what we call an intelligent decision. So I've taken the liberty of doing that. I move this down ever so slightly. I subtract 2L from both sides, crosses that out. That leaves me W alone. Now I'm going to replace W with that. Classic substitution. I'm going to multiply it out. Then I'm going to take the derivative. I'm also going to move the M to this side because it just annoys the hell out of me that it's on that side. It's on the wrong side. I mean, I could have solved that problem in the beginning by just having that M over there. Whatever. Doesn't matter. So, poof. The M has moved to that side. I distribute the L. I get 2,400L minus 2L squared. Now I'm ready to take M prime. Derivative of 2,400L is 2,400. The derivative of negative 2L squared multiplied by the power, subtract 1. You get 4L. Now what are you supposed to do with this? Set it equal to 0. And again, I'll write it on the side like you're in the 3rd grade. Oh, I'm keeping my fingers crossed I did this right. 20. I mean, there's no point in you watching my back while I write all this. That's why I constantly stop it. 2,400 minus 4L is 0. Add 4L to both sides. Divide by 4. Pow! L is 600. What do I do? What do I do? I don't know what this means. It means that this side is 600. And this side is 600. Now you gotta do is figure out this side. Well, this is not difficult. I mean, if you can't tell, it's 1,200. Then just keep watching. And you'll be surprised. You'll be like, whoa, it's like magic. I gotta write it all out, and I guess I gotta talk while I do it. So, there you go. Oh, interesting. Okay. So my picture's a little off, right? I mean, actually, it's like 600. 1200, and then 600. I don't know if it's going to cut off at the bottom, so I'm putting it there. And it just slap. What the hell? That looks like 128. Nice. 1200. There we go. So this is actually what it looks like. I should have made some effort to be neat. So anyway, I made myself a picture. I made my two equations. I had to solve one of them for one of the letters. It's easier to solve for W. Plug it in. Take my max equation. Take the derivative of my max equation. Set it equal to 0. Solve for one of the letters. Go back and plug that letter in and solve for the second letter. Pow. So I know that my pasture, Cletus's pasture, has to be 600 by 1200. Or whatever. Or 12 by 6. Two lengths of 600, it matters. The length is 600. Okay? Because there's two of them. You can't have two 1200s that has all this fencing. And it's only two sides. Alright, so just be careful. You label everything right. Now I'm going to do one that is, unfortunately, much, much harder. And it's usually the one that shows up on the final. Now, before I do this monstrosity of a problem that comes next, that you won't like, I want to remind you of how to do a little algebraic manipulation. So look, this requires you to cross multiply. I like to call it crisscross applesauce, right? You put a 1 there. Crisscross. This one goes to there. X times x squared is x cubed. And then 16 just stays there. Basically, just bring this one over to that side. I mean, it's kind of stupid to crisscross. There's nothing there to crisscross. Then you would divide by 2. You get x cubed equals 8. And then you'd have to take the cube root of 8, which is 2. Now you're saying, what the hell are you doing this for? This next problem I do is remarkably complex. This is what happens when you get to the end of the next problem. And I just wanted to remind you of what the hell to do when you get here. Because a lot of people actually get here and then they don't know what the hell to do. They get stuck. They're like, what? I don't know how to solve this. Crisscross. It's really easy to do, all right? This next one is very, very nasty. So this is just to get you prepared for it. So take a deep breath and prepare yourself. All right. There is the horror. Prepare yourself. We're going to read it together. I will not be able to finish this problem in a board. I guarantee you I'll have to erase probably even twice. Maybe once. You have a box with a square base and an open top. And it must have a volume of 108 inches cubed. Cubic inches, right? Volume, length, width, height. Find the dimensions that will minimize, not maximize, minimize, the surface. What the hell is surface area of the box? I don't even know what that means. Look, you're building a box. It takes material to build a box. The sides, the bottom, the top. Now this one has an open top, but the bottom and the 4 sides. Each one uses material to build. You want your box to have a volume of 108, all right? You want your box to have a certain volume. But you're cheap. You don't want to spend a lot of money. So you want to minimize the sides, the amount of material that you use to build the sides. So I'm going to try really hard to make a box. And it's going to look like crap. I apologize for it. Now, it says square base. So I'm trying to decide with the cube I drew which one looks like the bottom to me. Let's pretend this is the bottom. Okay, so there's my bottom. Now, the bottom is a square. That means the length and the width. You didn't draw it like a square. I did the best I could. I'm only human. The bottom is a square. Now, so that means that the sides are equal. I don't know what the hell this is, right? Length, width, height. The room that you're sitting in right now, wherever you are, you're sitting in a room, unless you're outside in the park, which you probably aren't. So if you're in a room right now, your room has a volume. The volume of the room you're in is the length times the width times the height. The length and width of the floor and the height of the wall. Okay, so think of the box the same way. Length and width is your floor. The height is the wall. So I need the volume first. Okay, so the volume, length, width, height, right? Volume is length times width times height. The length and width I'm calling X. The height I'm calling H. Why? because height starts with H. And what did I say in the problem? Must have volume of. So the volume must be 108. Well, there I go. Yay, I have an equation. Now, I don't need to write the V anymore. This is my first equation. This is the equation for the volume of the box, right? You want to keep the V there, whatever. But I already have an equal here. Now, this is the problem. I need to minimize what? The surface area. This is very complex. Surface area is, just listen really carefully to what I say. The surface area is the area of each of the surfaces. And there are 5 of them. There's a bottom and 4 sides. Open top, wherever the hell that is. There it is, open top. There is no top, all right? Or there would be another side. This box only has 5 sides, a bottom and 4 sides going around. The surface area is the area of each one of the surfaces. So, what's the area of the bottom? Well, the bottom is a square base. So the bottom has an area of x squared. Now, the side. Here's a side. Right? So, a side would be over here. Over here. The area of that side is the length times the width. But the length is x. The width is the height. So you have 4 sides, right? And every one of those sides has an area of the length, which is x, and the width, which is h. They're all rectangles, right? The box, the bottom is a square. So I can say x and x, or you wouldn't even be able to do this question. So each of the sides, though, is a rectangle. And a rectangle has an area of length times width. The length is x, the width is h. All right, so surface area means you take the area of all of the sides and the area of the bottom. Those are the surfaces that make a box when you put them all together. Okay, so this is what you're trying to minimize. Now you should be thinking to yourself, oh my God, this is an effing disaster. And it is, because you have to take this one. Now, let's use a little intelligence here. I have to solve this for one of the letters and plug it into here. If you think, oh, I'm going to solve for x squared, and then replace that. But what about this x? In order to solve this for x, you'd have to divide by h, and then take the square root of both sides. If you attempt to solve this for x, you are a moron, and you should just not even do this problem. You need to stop and go do something else. All right? I don't know what I would say in the class. I'd say, go home. But you are home. So you're not solving for x here. FT on that. You're going to solve for h. Look, there's only one h here. There's only one h. You got to get rid of it. So you're going to solve that one for h and plug it in, okay? I'm going to do this on the side. All right, so to try to save time, this lesson is going to be ridiculously long because of this one example. I solve for h. How? Divide both sides by x squared. Now, take this h and put 108 over x squared in there. You can't leave this like this. You do not want to attempt to take the derivative right now. You got to neaten up before you do it. So I'm going to do that. First of all, you don't have to multiply this, but I'm going to. 4 times 100 is 400, and 4 times 8 is 32. So I know what it is. Now, here's the part that you got to be really careful about. I have x and I have x squared. That's going to leave me an x on the bottom, right? If I have x over x squared, that's 1 over x. Now, you're going to take the derivative like this? No, you're not. I've told you time and time and time again, when you have a fraction with the x on the bottom, you have to rewrite it so that you're able to take the derivative with the power rule. All right? Like if you had 1 over x to the third. What are you going to do? You're going to take the derivative and say, oh, it's 1 over 3x squared. No, it's not. You'd have to write this as x to the minus 3 power. So you're going to do a similar thing here. This x gets knocked out by one of those. There's 2 x's down there. So they cross out. You get 1 over x. You need to then rewrite it as x to the minus 1 so that you can use the power rule. You must do this. You cannot leave it. I'm going to use the quotient rule. Good for you. You get it wrong, and I'll mark it wrong just on principle. Anyway, so this is what you get when you neaten it up. You get x squared plus. Now, I probably could fit it, but I don't want to push my luck. I'm going to take the derivative of this. So I'm going to erase most of this, and I'm going to start from there. You won't even know. So poof. I've erased the rest of the insanity. I got my minimal equation, right? I mean, I can still call it max equation, even though it's min. But see, M for min. That's why I use M, because it works for min and max. Now I got to take the derivative. Now be careful. Derivative of x squared is 2x. Multiply by the power. 432 times negative 1, right? Sign switches. Subtract 1 off the power. Don't do nothing dumbass here. It's x to the 0. No, it's not. Okay? Be careful. You're subtracting 1 from 1. Now, what are you supposed to do? Set it equal to 0. What the hell am I supposed to do with that? I don't know what to do with that. This is crazy. You can't solve this with a negative power. This is the stupidest thing I've ever seen in my whole life. Well, yeah. Take the negative exponent and put it back down. You moved it up so that you could take the derivative of it, but now you need to rewrite it. Now, this is going to look real familiar in a minute if it doesn't already, from what I was reminding you before. So, once you take the derivative, you get a negative exponent. You move it back down. Now, add that to the other side. So basically, this is just going to turn into an equal. Ooh, it looks familiar. I've seen this before. Crisscross applesauce. Crisscross, bring him over there. Divide by 2. I'm going to do the whole whammy. So what, 216? Half of 4 is 2, and then half of 32 is 16. I cheat. Now you got to take the cube root of this. Look, you use your calculator, right? I'll make the answer come out to like 8 or 27, so you know what it is. I'm pretty sure you know the cube root of 27, the cube root of 8. I'm pretty sure that's 6 times 6 times 6. So understand the steps. The previous steps, I wrote my equations down. I solved for h. I plugged in h, and I simplified, and I got my max equation. I took that max equation, and I took the derivative of it, and I set it equal to 0. I ended up with some crazy insanity here that I had to solve. I ended up with something cubed, and then I got x. Now, once you know x, then you go back and you get h. So I know that x is 6. I think it's 3. 36, 36, 36. Right? 36 and 36, 72. 72 and 36 again is 108. So what are the dimensions of the box you built? 6 by 6 by 3. Right? What's a box? Length, width, height. There you go. If you multiply that out, you get 108. So if you're going to make a box of that volume and you want to minimize the amount of material that you use to build that box, you would make this 6 inches by 6 inches by 3 inches. Now that's a pretty tiny box, but whatever. I mean, I could have used a different unit of measure. All right, so this is the hard, monstrous problem that usually shows up on the final, and you'll have quite a few of these on the next worksheet. So as always, I will wish you good luck.